Antarctica. Antarctica, or listen, is Earth's southernmost continent. It contains the geographic South Pole and is situated in the Antarctic region of the Southern Hemisphere, almost entirely south of the Antarctic Circle, and is surrounded by the Southern Ocean. At 14,200,000 square kilometers, 5,500,000 square miles, it is the fifth largest continent and nearly twice the size of Australia. It is by far the least populated continent, with around 5,000 people in the summer and around 1,000 in the winter. About 98% of Antarctica is covered by ice that averages 1.9 km, 1.2 mi, 6,200 ft in thickness, which extends to all but the McMurdo Dry Valleys and the northernmost reaches of the Antarctic Peninsula. Antarctica, on average, is the coldest, driest, and windiest continent, and has the highest average elevation of all the continents. Most of Antarctica is a polar desert, with annual precipitation of 200 mm 7.9 in along the coast and far less inland, yet 80% of the world freshwater reserves are stored there, enough to raise global sea levels by about 60 meters 200 ft if all of it were to melt. The temperature in Antarctica has dropped to 89.2 deg C 128.6 deg F, or even 94.7 deg C 135.8 deg F as measured from space, though the average for the third quarter, the coldest part of the year, is 63 deg C 81 deg F. Organisms native to Antarctica include many types of algae, bacteria, fungi, plants, protista, and certain animals such as mites, nematodes, penguins, seals, and tardigrades. Vegetation, where it occurs, is tundra. Antarctica was the last region on Earth to be discovered, likely unseen until 1820, when the Russian expedition of Fabian Gottlieb von Bellingshausen and Mikhail Lazaire von Vostok and Murnay sighted the Fimbul ice shelf. The continent remained largely neglected for the rest of the 19th century because of its harsh environment, lack of easily accessible resources, and isolation. In January 1840, land at Antarctica was discovered for the first time, almost simultaneously, by the United States exploring expedition under Lieut. Charles Wilkes and a separate French expedition under Jules Dumont d'Urville. The latter made a temporary landing. The Wilkes expedition, though it did not make a landing, remained long enough in the region to survey and map some 800 miles of the continent. The first confirmed landing was by a team of Norwegians in 1895. Antarctica is governed by parties to the Antarctic Treaty system. 12 countries signed the Antarctic Treaty in 1959, and 38 have signed it since then. The treaty prohibits military activities, mineral mining, nuclear explosions, and nuclear waste disposal. It supports scientific research and protects the continent's ecology. Between 1,000 and 5,000 people from many countries reside at research stations scattered across the continent. Etymology. The name Antarctica is the Romanized version of the Greek compound word Antarktike, Antarctique, feminine of Antarcticos, Antarcticos, meaning opposite to the Arctic, opposite to the north. Aristotle wrote in his book Meteorology about an Antarctic region in c. 350 BC. Marinus of Tyre reportedly used the name in his unpreserved world map from the 2nd century CE. The Roman authors Hyginus and Apuleius 2 centuries CE used for the South Pole the Romanized Greek name Polus Antarcticus, from which derived the Old French Pole Antarctique, modern Pole Antarctica, tested in 1270, and from there the Middle English Pol Antarctic in a 1391 technical treatise by Geoffrey Chaucer, a treatise on the astrolabe. Matthias Ringman called Terra Australis the Ora Antarctica, Antarctic land, in 1505. Change of name. The long imagined but undiscovered South Polar Continent was originally called Terra Australis, sometimes shortened to Australia, as seen in a woodcut illustration titled Sphere of the Winds, contained in an astrological textbook published in Frankfurt in 1545. In the early 19th century, the colonial authorities in Sydney removed the Dutch name from New Holland. Instead of inventing a new name to replace it, they took the name Australia, leaving the South Polar continent nameless for some 80 years. During that period, geographers had to make do with clumsy phrases such as the Antarctic continent. They searched for a more poetic replacement, suggesting various names such as Ultima and Antipodia. Eventually, Antarctica was adopted as the continental name. In the 1890s, the first use of the name is attributed to the Scottish cartographer John George Bartholomew. History of exploration. Antarctica has no indigenous population. According to Maori oral history in New Zealand, Huiti Rangira, also known as Uiti Rangira, and his crew explored Antarctic waters in the early 7th century on the vessel Te Ivio 80. Accounts name the area Te Tai Yuko Apaya, which describes a frozen ocean, and arrowroot, which resembles fresh snow when scraped. The oldest known human remains in Antarctica was a skull that belonged to a young Yagan woman on Yamana Beach at the South Shetland Islands, which dates back to 1819 to 1825. She was found in 1985. Belief in the existence of a Terra Australis, a vast continent in the far south of the globe to balance the northern lands of Europe, Asia, and North Africa had prevailed since the times of Ptolemy in the 1st century AD. Even in the late 17th century, after explorers had found that South America and Australia were not part of the fabled Antarctica, geographers believed that the continent was much larger than its actual size. Integral to the story of the origin of Antarctica's name is that it was not named Terra Australis. This name was given to Australia instead because of the misconception that no significant landmass could exist further south. Explorer Matthew Flinders, in particular, has been credited with popularizing the transfer of the name Terra Australis to Australia. He justified the titling of his book A Voyage to Terra Australis 1814 by writing in the introduction, "There is no probability that any other detached body of land of nearly equal extent will ever be found in a more southern latitude. The name Terra Australis will therefore remain descriptive of the geographical importance of this country and of its situation on the globe. It has antiquity to recommend it, and having no reference to either of the two claiming names." European maps continued to show this hypothetical land until Captain James Cook's ships, HMS Resolution and Adventure, crossed the Antarctic Circle on 17 January 1773, in December 1773, and again in January 1774. Cook came within about 120 km 75 mi of the Antarctic coast before retreating in the face of field ice in January 1773. In 1775, Cook called the existence of a polar continent probable, and in another copy of his journal he wrote, "I firmly believe it, and it's more than probable, that we have seen a part of it." According to various organizations, the National Science Foundation, NASA, the University of California, San Diego, the Russian State Museum of the Arctic and Antarctic, among others, ships captained by 3 men sighted Antarctica or its ice shelf in 1820. Fabian Gottlieb von Bellingshausen, a captain in the Imperial Russian, the first Russian Antarctic expedition led by Bellingshausen and Mikhail Lazarev on the 985-ton sloop of war Vostok East and the 530-ton support vessel Mirny Peaceful, reached a point within Thur on 27 January 1820, which became known as the Fimbul Ice Shelf. This happened 3 days before Bransfield sighted the land of the Trinity Peninsula of Antarctica, as opposed to the ice of an ice shelf, and 10 months before Palmer did so in November 1820. The first documented landing on Antarctica was by the American sealer John Davis, apparently at Hughes Bay near Cape Charles in West Antarctica on 7 February 1821, although some historians dispute this claim. The first recorded and confirmed landing was at Cape Adare in 1895 by the Norwegian-Swedish whaling ship Antarctic. On 22 January 1840, 2 days after the discovery of the coast west of the Balleny Islands, some members of the crew of the 1837-40 expedition of Jules Dumont d'Urville disembarked on the highest islet of a group of coastal rocky islands about 4 km from Cape Giudese on the coast of Adelie Landway. Algae and animal samples. Explorer James Clark Ross passed through what is now known as the Ross Sea and discovered Ross Island, both of which were named after him in 1841. He sailed along a huge wall of ice that was later named the Ross Ice Shelf. Mount Erebus and Mount Terror are named after two ships from his expedition, HMS Erebus and Terror. Mercator Cooper landed in East Antarctica on 26 January 1853. During the Nimrod expedition led by Ernest Shackleton in 1907, parties led by Edgeworth David became the first to climb Mount Erebus and to reach the South Magnetic Pole. Douglas Mawson, who assumed the leadership of the Magnetic Pole Party on their perilous return, went on to lead several expeditions until retiring in 1931. In addition, Shackleton and three other members of his expedition made several firsts. In December 1908, February 1909, they were the first humans to traverse the Ross Ice Shelf, the first to traverse the Transantarctic Mountains via the Beardmore Glacier, and the first to set foot on the South Polar Plateau. An expedition led by Norwegian polar explorer Roald Amundsen from the ship Fram became the first to reach the geographic South Pole on 14 December 1911, using a route from the Bay of Whales and up the Axel Heiberg Glacier. 1 month later, the Dune Scott expedition reached the pole. Richard E. Byard led several voyages to the Antarctic by plane in the 1930s and 1940s. He is credited with implementing mechanized land transport on the continent and conducting extensive geological and biological research. The first women to set foot on Antarctica were Caroline Michelson, who landed on an island of Antarctica in 1935, and Ingrid Christensen, who stepped onto the mainland in 1937. It was not until 31 October 1956 that anyone set foot on the South Pole again. On that day, a U.S. Navy group led by Rear Admiral George J. Dufek successfully landed an aircraft there. The first women to step onto the South Pole were Pam Young, Jean Pearson, Lois Jones, Eileen McSaveny, Kay Lindsay, and Terry Tickhill in 1969. In the Southern Hemisphere summer of 1996-97, the Norwegian explorer Borge Ausland became the first person to cross Antarctica alone from coast to coast. Ausland got aid from a kite on parts of the distance. All attempted crossings, with no kites or resupplies, that have tried to go from the true continental edges, where the ice meets the sea, have failed due to the great distance that needs to be covered. For this crossing, Ausland also holds the record for the fastest unsupported journey to the South Pole, taking just 34 days. Geography. Positioned asymmetrically around the South Pole and largely south of the Antarctic Circle, Antarctica is the southernmost continent and is surrounded by the Southern Ocean. Alternatively, it may be considered to be surrounded by the Southern Pacific, Atlantic, and Indian Oceans, or by the southern waters of the World Ocean. There are a number of rivers and lakes in Antarctica, the longest river being the Onyx. The largest lake, Vostok, is one of the largest subglacial lakes in the world. Antarctica covers more than 14 million km to 5,400,000 sq mi, making it the fifth largest continent, about 1.3 times as large as Europe. The coastline measures 17,968 km, 11,165 mi, and is mostly characterized by ice formations, as the following table shows. Antarctica is divided in two by the Transantarctic Mountains close to the neck between the Ross Sea and the Weddell Sea. The portion west of the Weddell Sea and east of the Ross Sea is called West Antarctica, and the remainder East Antarctica. About 98% of Antarctica is covered by the Antarctic ice sheet, a sheet of ice averaging at least 1.6 km, 1.0 mi thick. The continent has about 90% of the world's ice and thus about 70% of the world's fresh water. If all of this ice were melted, sea levels would rise about 60 m 200 ft. In most of the interior of the continent, precipitation is very low, down to 20 mm 0.8 in per year, In a few blue ice areas, precipitation is lower than mass loss by sublimation, and so the local mass balance is negative. In the dry valleys, the same effect occurs over a rock base, leading to a barren and desiccated landscape. West Antarctica is covered by the West Antarctic ice sheet. The sheet has been of recent concern because of the small possibility of its collapse. If the sheet were to break down, ocean levels would rise by several meters in a relatively short geological period of time, perhaps a matter of centuries. Several Antarctic ice streams flow to one of the many Antarctic ice shelves, a process known as ice sheet dynamics. East Antarctica lies on the Indian Ocean side of the Transantarctic Mountains and comprises Coates Land, Queen Maud Land, Enderby Land, Mac. Robertson Land, Wilkes Land, and Victoria Land. All but a small portion of this region lies within the Eastern Hemisphere. East Antarctica is largely covered by the East Antarctic ice sheet. Vinson Massif, the highest peak in Antarctica at 4,892 m 16,050 ft, is located in the Ellsworth Mountains. Antarctica contains many other mountains on both the main continent and the surrounding islands. Mount Erebus on Ross Island is the world's southernmost active volcano. Another well-known volcano is found on Deception Island, which is famous for a giant eruption in 1970. Minor eruptions are frequent, and lava flow has been observed in recent years. Other dormant volcanoes may potentially be active. In 2004, a potentially active underwater volcano was found in the Antarctic Peninsula by American and Canadian researchers. Antarctica is home to more than 70 lakes that lie at the base of the continental ice sheet. Lake Vostok, discovered beneath Russia's Vostok Station in 1996, is the largest of these subglacial lakes. It was once believed that the lake had been sealed off for 500,000. There is some evidence in the form of ice cores drilled to about 400 and 1,300 ft above the water line. The frozen surface of the lake shares similarities with Jupiter's moon Europa. If life is discovered in Lake Vostok, it would strengthen the argument for the possibility of life on Europa. In 2008, a NASA team embarked on a mission to Lake Untersee, searching for extremophiles in its highly alkaline waters. If found, highly resilient creatures could further bolster the argument for extraterrestrial life in extremely cold, methane-rich environments. In September 2018, researchers at the National Geospatial Intelligence Agency released a high-resolution terrain map detailed down to the size of a car, and less in some areas of Antarctica, named the Reference Elevation Model of Antarctica REMAP. Geologic history. From the end of the Neoproterozoic to the Cretaceous, Antarctica formed part of the supercontinent Gondwana. Over time, Gondwana gradually broke apart, and Antarctica, as we know it today, was formed around 25 million years ago, when the Drake Passage opened between it and South America. Antarctica was not always cold, dry, and covered in ice sheets. At a number of points in its history, it was farther north, experienced a tropical or temperate climate, and was covered in forests. Paleozoic era 540–250 Ma. During the Cambrian period, Gondwana had a mild climate. West Antarctica was partially in the northern hemisphere, and during this period large amounts of sandstones, limestones, and shales were deposited. East Antarctica was at the equator, where seafloor invertebrates and trilobites flourished in the tropical seas. By the start of the Devonian period 416 Ma, Gondwana was in more southern latitudes, and the climate was cooler, though fossils of land plants are known from this time. Sand and silts were laid down in what is now the Ellsworth, Horlick, and Pensacola Mountains. Antarctica became glaciated during the late Paleozoic icehouse beginning at the end of the Devonian period 360 Ma, though glaciation would substantially increase during the late Carboniferous. As Antarctica drifted closer to the South Pole and the climate cooled, though flora remained. After deglaciation during the latter half of the early Permian, the land became dominated by glossopterids, an extinct group of seed plants with no close living relatives, most prominently Glossopteris, a tree which is interpreted as growing in waterlogged soils, which formed extensive coal deposits. Other plants found in Antarctica during the Permian include chordatails, sphenopsids, ferns, and lycophytes. At the end of the Permian, the eruption of the Siberian traps led to a dry, hot climate over much of Gondwana and the collapse of the glossopterid forest ecosystems. There is no evidence of any tetrapods having lived in Antarctica during the Paleozoic. Mesozoic era 250-66 Ma. As a result of continued warming, much of Gondwana became arid. During the Triassic, Antarctica was dominated by seed ferns or pteridosperms belonging to the genus Dicroidium, which grew as trees. Other associated Triassic flora includes ginkgophytes, cycadophytes, conifers, and sphenopsids. Tetrapods first appeared in Antarctica during the earliest Triassic, with the earliest known fossils being in the Fremau Formation in the Transantarctic Mountains. Synapsids, commonly known as mammal-like reptiles and which included species such as Lystrosaurus, were common in Antarctica during the early Triassic. The Antarctic Peninsula began to form during the Jurassic period 206–146 Ma. Ginkgo trees, conifers, bennettitales, horsetails, ferns, and cycads were plentiful during this period. In West Antarctica, coniferous forests dominated through the entire Cretaceous period 146–66 Ma, though southern beech Nothofagus became more prominent towards the end of this period. Ammonites were common in the seas around Antarctica, and dinosaurs were also present, though only a few Antarctic dinosaur genera Cryolophosaurus and Glacialosaurus, from the early Jurassic Hansen Formation of the Transantarctic Mountains, and Antarctoplu, Trinosaura, Morosaurus, and Imperabator from late Cretaceous of the Antarctic Peninsula have. It was during this era that Gondwana began to break up. Gondwana breakup 160–23 Ma. The cooling of Antarctica occurred stepwise, as the continental spread changed the oceanic currents from longitudinal equator to pole temperature equalizing currents to latitudinal currents that preserved and accentuated latitude temperature differences. Africa separated from Antarctica in the Jurassic, around 160 Ma, followed by the Indian subcontinent in the early Cretaceous, about 125 Ma. By the end of the Cretaceous, about 66 Ma, Antarctica then connected to Australia. In the Eocene epoch, about 40 Ma, Australia and New Guinea separated from Antarctica, so that latitudinal currents could isolate Antarctica from Australia, and the first ice began to appear. During the Eocene-Oligocene extinction event about 34 million years ago, sea atoll levels have been found to be about 760 ppm and had been decreasing from earlier levels in the thousands of ppm. Around 25 Ma, the Drake Passage opened between Antarctica and South America, resulting in the Antarctic Circumpolar Current that completely isolated the continent. Models of the changes suggest that declining sea atoll levels became more important. The ice began to spread, replacing the forests that until then had covered the continent. Since about 15 Ma, the continent has been mostly covered with ice. Pliocene and Pleistocene. Fossil Nothofagus leaves in the Mayer Desert Formation of the Sirius Group show. After that, the Pleistocene Ice Age covered the whole continent and destroyed all major plant life on it. A study from 2014 estimated that during the Pleistocene, the East Antarctic ice sheet thinned by at least 500 m 1600 ft, and that thinning since the last glacial maximum for the EAS area is less than 50 m 160 ft and probably started after c. 14 Ca. About 2200 years ago, a volcano erupted under Antarctica's ice sheet, as detected by an airborne survey with radar images. The biggest eruption in Antarctica in the last 10,000 years, the volcanic ash was found deposited on the ice surface under the Hudson Mountains, close to Pine Island Glacier. Present day, the geological study of Antarctica has been greatly hindered by nearly all of the continent being permanently covered with a thick layer of ice. However, new techniques such as remote sensing, ground-penetrating radar, and satellite imagery have begun to reveal the structures beneath the ice. Geologically, West Antarctica closely resembles the Andes mountain range of South America. The Antarctic Peninsula was formed by uplift and metamorphism of seabed sediments. The most common rocks in West Antarctica are andesite and rhyolite volcanics formed during the Jurassic period. There is also evidence of volcanic activity, even after the ice sheet had formed, in Marie Bioid Land and Alexander Island. The only anomalous area of West Antarctica is the Ellsworth Mountains region, where the stratigraphy is more similar to East Antarctica. East Antarctica is geologically varied, dating from the Precambrian era, with some rocks formed more than 3 billion years ago. It is composed of a metamorphic and igneous platform, which is the basis of the continental shield. On top of this base are coal and various modern rocks, such as sandstones, limestones, and shales laid down during the Devonian and Jurassic periods to form the Transantarctic Mountains. In coastal areas such as the Shackleton Range and Victoria Land, some faulting has occurred. The main mineral resource known on the continent is coal. It was first recorded near the Beardmore Glacier by Frank Wild on the Nimrod expedition, and now low-grade coal is known across many parts of the Transantarctic Mountains. The Prince Charles Mountains contain significant deposits of iron ore. The most valuable resources of Antarctica lie offshore, namely the oil and natural gas fields found in the Ross Sea in 1973. Exploitation of all mineral resources is banned until 2048 by the Protocol on Environmental Protection to the Antarctic Treaty. Climate. Regional climate. East Antarctica is colder than its western counterpart because of its higher elevation. Weather fronts rarely penetrate far into the continent, leaving the center cold and dry. Despite the lack of precipitation over the central portion of the continent, ice there lasts for extended periods. Heavy snowfalls are common on the coastal portion of the continent, where snowfalls of up to 1.22 meters 48 in 48 hours have been recorded. At the continent's edge, strong katabatic winds off the polar plateau often blow at storm force. In the interior, wind speeds are typically moderate. During clear days in summer, more solar radiation reaches the surface at the South Pole than at the equator because of the 24 hours of sunlight each day at the pole. Antarctica is colder than the Arctic for 3 reasons. First, much of the continent is more than 3,000 m 9,800 ft above sea level, and temperature decreases with elevation in the troposphere. Second, the Arctic Ocean covers the North Polar Zone. The ocean's relative warmth is transferred through the ice pack and prevents temperatures in the Arctic regions from reaching the extremes typical of the land surface of Antarctica. Third, the Earth is at aphelion in July, i.e., the Earth is farthest from the Sun in the Antarctic winter, and the Earth is at perihelion in January, i.e., the Earth is closest to the Sun in the Antarctic summer. The orbital distance contributes to a colder Antarctic winter and a warmer Antarctic summer, but the first 2 effects have more impact. Climate change. Some of Antarctica has been warming up. Particularly strong warming has been noted on the Antarctic Peninsula. A study by Eric Stagg published in 2009 noted for the first time that the continent-wide average surface temperature trend of Antarctica was slightly positive from 1957 to 2006. Over the second half of the 20th century, the Antarctic Peninsula was the fastest warming place on Earth, closely followed by West Antarctica. But these trends weakened in the early 21st century. Conversely, the South Pole in East Antarctica barely warmed last century, but temperatures shall have 3 times the global average in the last 3 decades. In February 2020, the continent recorded its highest temperature of 18.3 deg C 64.9 deg F, which was a degree higher than the previous record of 17.5 deg C 63.5 deg F in March 2015. There is some evidence that surface warming in Antarctica is due to human greenhouse gas emissions, but this is difficult to determine due to internal variability. A main component of climate variability in Antarctica is the southern annular mode, which showed strengthened winds around Antarctica in summer of the later decades of the 20th century, associated with cooler temperatures over the continent. The trend was at a scale unprecedented over the last 600 years. The most dominant driver of this mode of variability is likely the depletion of ozone above the continent. In 2002, the Antarctic Peninsula's Larsen B ice shelf collapsed. Between 28 February and 8 March 2008, about 570 km to 220 sq mi of ice from the Wilkins ice shelf on the southwest part of the peninsula collapsed, putting the remaining 15,000 km to 5,800 sq mi of the ice shelf at risk. The ice was being held back by a thread of ice about 6 km 4 mi wide prior to its collapse on 5 April 2009. Ice loss and global sea level. Due to its location at the South Pole, Antarctica receives relatively little solar radiation except along the southern summer. This means that it is a very cold continent where water is mostly in the form of ice. Precipitation is low. Most of Antarctica is a desert and almost always in the form of snow, which accumulates and forms the giant ice sheets which cover the continent. Parts of this ice sheet form moving glaciers known as ice streams, which flow towards the edges of the continent. Next to the continental shore are many ice shelves. These are floating extensions of outflowing glaciers from the continental ice mass. Offshore, temperatures are also low enough that ice is formed from seawater through most of the year. Sea ice and ice shelves. Sea ice extent expands annually in the Antarctic winter, but most of this ice melts in the summer. This ice is formed from the ocean water and floats in the same water, and thus does not contribute to a rise in sea level. The extent of sea ice around Antarctica, in terms of square kilometers of coverage, has seen no significant trend in the satellite era 1978-2018, with initial growth being reversed in the last years of the record. A possible explanation for the difference between the Antarctic and the Arctic, which has seen rapid sea ice loss, is that thermohaline circulation transports warmed water to deeper layers in the ocean. The amount of variation it has experienced in its thickness is unclear, with satellite techniques just emerging as of 2019. Melting of floating ice shelves. Ice that originated on the land does not in itself contribute much to sea level rise, since the ice displaces only its own mass of water. However, ice sheets work as a stabilizer of the land ice and are vulnerable to warming water. Recent decades have witnessed several dramatic collapses of large ice shelves around the coast of Antarctica, especially along the Antarctic Peninsula. This loss of ice shelf buttressing has been identified as the major cause of ice loss on the West Antarctic ice sheet, but has also been observed around the East Antarctic ice sheet. Ice sheet loss and sea level rise. The Antarctic ice sheet is losing mass as ice flows faster into the ocean than before. This effect is partially offset by additional snow falling back onto the continent. A 2018 systematic review study estimated the total contribution to sea level rise has been estimated as 8 mm to 14 mm of sea level rise. On the continent itself, the large volume of ice present stores around 70% of the world's fresh water. East Antarctica is a cold region with a ground base above sea level and occupies most of the continent. This area is dominated by small accumulations of snowfall which becomes ice and thus eventually seaward glacial flows. Estimates of the mass balance of the East Antarctic ice sheet as a whole range from slightly positive to slightly negative. Increased ice outflow has been observed in some regions. Future projections of ice loss depend on the speed of climate change mitigation and are uncertain. Tipping points have been identified in some regions. When a certain threshold warming is reached, these regions may start melting significantly faster and irreversibly. That is, even when temperatures come down again, the ice will not immediately regrow. Ozone depletion. There is a large area of low ozone concentration or ozone hole over Antarctica. The hole, reoccurring every spring since the 1970s, was detected by scientists in 1985. This hole covers almost the whole continent and was at its largest in September 2006. The longest-lasting event occurred in 2020. The ozone hole is attributed to the emission of chlorofluorocarbons, or CFC, into the atmosphere, which decompose the ozone into other gases. In 2019, the ozone hole was at its smallest in the previous 30 years, due to the warmer polar stratosphere weakening the polar vortex. This reduced the formation of the polar stratospheric clouds that enable the chemistry that leads to rapid ozone loss. Ozone depletion may have a dominant role in governing climatic change in Antarctica and a wider area of the Southern Hemisphere. Ozone absorbs large amounts of ultraviolet radiation in the stratosphere. Ozone depletion over Antarctica can cause a cooling of around 6 deg C in the local stratosphere. This cooling has the effect of intensifying the westerly winds which flow around the continent, the polar vortex, and thus prevents outflow of the cold air near the South Pole. As a result, the continental mass of the East Antarctic ice sheet is held at lower temperatures, and the peripheral areas of Antarctica, especially the Antarctic Peninsula, are subject to higher temperatures, which promote accelerated melting. Models suggest that ozone depletion and the enhanced polar vortex effect also account for the period of increased sea ice just offshore of the continent. Biodiversity. The terrestrial and native year-round species appear to be the descendants of ancestors who lived in geothermally warmed environments during the last ice age, when these areas were the only places on the continent not covered by ice. Animals. Invertebrate life of Antarctica includes microscopic mites like the Elascozetes antarcticus, lice, nematodes, tardigrades, rotifers, krill, and springtails. The flightless midge Belgica antarctica, up to 6 mm 1/4 in size, is the largest purely terrestrial animal in Antarctica. Members of Chironomidae include Paraxylisteininae. Antarctic krill, which congregate in large schools, is the keystone species of the ecosystem of the Southern Ocean and is an important food organism for whales, seals, leopard seals, fur seals, squid, icefish, penguins, albatrosses, and many other birds. Few terrestrial vertebrates live in Antarctica, and those that do are limited to the subantarctic islands. Some species of marine animals exist and rely, directly or indirectly, on the phytoplankton. Antarctic sea life includes penguins, blue whales, orcas, colossal squids, and fur seals. The emperor penguin is the only penguin that breeds during the winter in Antarctica. It and the Adelie penguin breed farther south than any other penguin. The snow petrel is one of only 3 birds that breed exclusively in Antarctica. The Antarctic Fur Seal was very heavily hunted in the 18th and 19th centuries for its pelt by sealers from the United States and the United Kingdom. The Weddell Seal, a true seal, is named after Sir James Weddell, commander of British sealing expeditions in the Weddell Sea. The leopard seal is an apex predator in the Antarctic ecosystem, and they migrate across the Southern Ocean in search for food. A census of sea life carried out during the International Polar Year, and which involved some 500 researchers, was released in 2010. The research is part of the Global Census of Marine Life and has disclosed some remarkable findings. More than 235 marine organisms live in both polar regions, having bridged the gap of 12,000 km 7,456 mi. Large animals, such as some cetaceans and birds, make the round trip annually. More surprising are small forms of life such as sea cucumbers and free-swimming snails found in both polar oceans. Various factors may aid in their distribution: fairly uniform temperatures of the deep ocean at the poles and the equator, which differ by no more than 5 deg C, and the major current systems or marine conveyor belt, which transport eggs and larval stages. Fungi. About 1150 species of fungi have been recorded from Antarctica, of which about 750 are non-lichen-forming and 400 are lichen-forming. Some of these species are cryptondoliths as a result of evolution under extreme conditions, and have significantly contributed to shaping the impressive rock formations of the McMurdo Dry Valleys and surrounding mountain ridges. The apparently simple morphology, scarcely differentiated structures, metabolic systems and enzymes still active at very low temperatures, and reduced life cycles shown by such fungi make them particularly suited to harsh environments such as the McMurdo Dry Valleys. In particular, their thick-walled and strongly melanized cells make them resistant to UV light. Those features can also be observed in algae and cyanobacteria, suggesting that these are adaptations to the conditions prevailing in Antarctica. This has led to speculation that, if life ever occurred on Mars, it might have looked similar to Antarctic fungi such as Cryomyces antarcticus and Cryomyces minteri. Some of these fungi are also apparently endemic to Antarctica. Endemic Antarctic fungi also include certain dung-inhabiting species, which have had to evolve in response to the double challenge of extreme cold while growing on dung, and the need to survive passage through the gut of warm-blooded animals. Plants. About 300 million years ago, Permian forests started to cover the continent, and tundra vegetation survived as late as 15 million years ago, but the climate of present-day Antarctica does not allow extensive vegetation to form. A combination of freezing temperatures, poor soil quality, lack of moisture, and lack of sunlight inhibit plant growth. As a result, the diversity of plant life is very low and limited in distribution. The flora of the continent largely consists of bryophytes. There are about 100 species of mosses and 25 species of liverworts, but only 3 species of flowering plants, all of which are found in the Antarctic Peninsula: Dischampsia antarctica, Antarctic hairgrass, Colobanthus quietus, Antarctic pearlwort, and the non-native Poa annua annual bluegrass. Growth is restricted to a few weeks in the summer. Other organisms. 700 species of algae exist, most of which are phytoplankton. Multicolored snow algae and diatoms are especially abundant in the coastal regions during the summer. Bacteria have been found living in the cold and dark as deep as 800 m 0.50 mi, 2600 ft under the ice. Conservation. The Protocol on Environmental Protection to the Antarctic Treaty, also known as the Environmental Protocol or Madrid Protocol, came into force in 1998 and is the main instrument concerned with conservation and management of biodiversity in Antarctica. The Antarctic Treaty Consultative Meeting is advised on environmental and conservation issues in Antarctica by the Committee for Environmental Protection. A major concern within this committee is the risk to Antarctica from unintentional introduction of non-native species from outside the region. The passing of the Antarctic Conservation Act 1978 in the U.S. brought several restrictions to U.S. activity on Antarctica. The introduction of alien plants or animals can bring a criminal penalty, as can the extraction of any indigenous species. The overfishing of krill, which plays a large role in the Antarctic ecosystem, led officials to enact regulations on fishing. The Convention for the Conservation of Antarctic Marine Living Resources, CCAMLR, a treaty that came into force in 1980, requires that regulations managing all Southern Ocean fisheries consider potential effects on the entire Antarctic ecosystem. Despite these new acts, unregulated and illegal fishing, particularly of Patagonian toothfish marketed as Chilean sea bass in the U.S., remains a serious problem. The illegal fishing of toothfish has been increasing, with estimates of 32,000 tons, 35,000 short tons in 2000. Population. Several governments maintain permanent, staffed research stations on the continent. The number of people conducting and supporting scientific research and other work on the continent and its nearby islands varies from about 1,000 in winter to about 5,000 in the summer, giving it a population density between 70 and 350 inhabitants per million square kilometers, 180 and 900 per million square miles at these times. Many of the stations are staffed year-round, the winter over personnel typically arriving from their home countries for a one-year assignment. An Orthodox church, Trinity Church, opened in 2004 at the Russian Bellingshausen station, is manned year-round by one or two priests, who are similarly rotated every year. The first semi-permanent inhabitants of regions near Antarctica areas situated south of the Antarctic convergence were British and American sealers who used to spend a year or more on South Georgia from 1786 onward. During the whaling era, which lasted until 1966, the population of that island varied from over 1,000 in the summer, over 2,000 in some years, to some 200 in the winter. Most of the whalers were Norwegian, with an increasing proportion of Britons. The settlements included Grytviken, Leith Harbour, King Edward Point, Stromness, Husvik, Prince Olav Harbour, Ocean Harbour, and Godfall. Managers and other senior officers of the whaling stations often lived together with their families. Among them was the founder of Grytviken, Captain Carl Anton Larsen, a prominent Norwegian whaler and explorer who, along with his family, adopted British citizenship in 1910. The first child born in the southern polar region was a Norwegian girl, Solveig Gunjord Jacobsen, born in Grytviken on 8 October 1913, and her birth was registered by the resident British magistrate of South Georgia. She was a daughter of Fridtjof Jacobsen, the assistant manager of the whaling station, and Clara Olette Jacobsen. Jacobsen arrived on the island in 1904 and became the manager of Grytviken, serving from 1914 to 1921. Two of his children were born on the island. Emilio Marcos Palma was the first person born south of the 60th parallel south, the firstborn on the Antarctic mainland, and the only living human to be the firstborn on any continent. He was born in 1978 at Esperanza Base, on the tip of the Antarctic Peninsula. His parents were sent there along with 7 other families by the Argentine government. In 1984, Juan Pablo Camacho was born at the Fray Montalva station, becoming the first Chilean born in Antarctica. Several bases are now home to families with children attending schools at the station. As of 2009, 11 children were born in Antarctica south of the 60th parallel south, 8 at the Argentine Esperanza base, and 3 at the Chilean Fray Montalva station. Politics, 6, politics, politics, 6, politics, politics. Several countries claim sovereignty in certain regions. While a few of these countries have mutually recognized each other's claims, the validity of these claims is not recognized universally. New claims on Antarctica have been suspended since 1959, although in 2015 Norway formally defined Queen Maud Land as including the unclaimed area between it and the South Pole. Antarctica's status is regulated by the 1959 Antarctic Treaty and other related agreements, collectively called the Antarctic Treaty System. Antarctica is defined as all land and ice shelves south of 6° for the purposes of the treaty system. The treaty was signed by 12 countries including the Soviet Union and later Russia, the United Kingdom, Argentina, Chile, Australia, and the United States. It set aside Antarctica as a scientific preserve, established freedom of scientific investigation, and environmental protection. Military activities banned. The Antarctic Treaty bans military activity on Antarctica. This was the first arms control agreement established during the Cold War. The Antarctic Treaty prohibits any military activity in Antarctica, including the establishment of military bases and fortifications, military maneuvers, and weapons testing. Military personnel or equipment are permitted only for scientific research or other peaceful purposes. The only documented military land maneuver has been the small Operation 90 by the Argentine military in 1965. Environmental protection. A coalition of international environmental protection organizations led largely by Greenpeace International launched a public campaign to pressure governments to prevent any minerals development in the region. Greenpeace International operated its own scientific station, World Park Base, in the Ross Sea region from 1987 until 1991, and conducted annual expeditions to document environmental effects. In 1983, the Antarctic Treaty parties began negotiations on a convention to regulate mining in Antarctica. In 1988, the Convention on the Regulation of Antarctic Mineral Resources (CRAMRA) was adopted. The following year, however, Australia and France announced that they would not ratify the convention, rendering it dead for all intents and purposes. They proposed instead that a comprehensive regime to protect the Antarctic environment be negotiated in its place. The Protocol on Environmental Protection to the Antarctic Treaty, the Madrid Protocol, was negotiated as other countries followed suit, and on 14 January 1998 it entered into force. The Madrid Protocol bans all mining in Antarctica, designating the continent as a natural reserve devoted to peace and science. To protect the marine environment in Antarctica, all ships over 500 tons are subject to mandatory regulations under the International Code for Ships Operating in Polar Waters, adopted by the International Maritime Organization on 1 January 2017. Antarctic territories. The Argentine, British, and Chilean claims all overlap and have caused friction. On 18 December 2012, the British Foreign and Commonwealth Office named a previously unnamed area Queen Elizabeth Land in tribute to Queen Elizabeth II's Diamond Jubilee. On 22 December 2012, the UK ambassador to Argentina, John Freeman, was summoned to the Argentine government as a protest against the claim. Argentine-UK relations had previously been damaged throughout 2012 due to disputes over the sovereignty of the nearby Falkland Islands and the 30th anniversary of the Falklands War. The areas shown as Australia's and New Zealand's claims were British territory until they were handed over following the country's independence. Australia currently claims the largest area. The claims of Britain, Australia, New Zealand, France, and Norway are all recognized by each other. Other countries participating as members of the Antarctic Treaty have a territorial interest in Antarctica, but the provisions of the treaty do not allow them to make their claims while it is in force. Brazil has a designated zone of interest that is not an actual claim. Peru has formally reserved its right to make a claim. Russia has inherited the Soviet Union's right to claim territory under the original Antarctic Treaty. South Africa has formally reserved its right to make a claim. United States reserved its right to make a claim in the original Antarctic Treaty. Economy. There is no current economic activity in Antarctica outside of fishing off the coast and small-scale tourism. Although coal, hydrocarbons, iron ore, platinum, copper, chromium, nickel, gold, and other minerals have been found, they have not been in large enough quantities to exploit. The 1991 Protocol on Environmental Protection to the Antarctic Treaty also restricts a struggle for resources. In 1998, a compromise agreement was reached to place an indefinite ban on mining to be reviewed in 2048, further limiting economic development and exploitation. The primary economic activity is the capture and offshore trading of fish. Antarctic fisheries in 2001 reported landing 112,934 tons. Small-scale expedition tourism has existed since 1957 and is currently subject to Antarctic Treaty and Environmental Protocol provisions, but in effect self-regulated by the International Association of Antarctica Tour Operators (IATO). Not all vessels associated with Antarctic tourism are members of IATO, but IATO members account for 95% of the tourist activity. Travel is largely by small or medium ship, focusing on specific scenic locations with accessible concentrations of iconic wildlife. A total of 37,506 tourists visited during the 2006-07 austral summer, with nearly all of them coming from commercial ships. 38,478 were recorded in 2015-16. As of 2018, there are 2 Wells Fargo ATM in Antarctica, both located at McMurdo Station. There has been some concern over the potential adverse environmental and ecosystem effects caused by the influx of visitors. Some environmentalists and scientists have made a call for stricter regulations for ships and a tourism quota. The primary response by Antarctic Treaty parties has been to develop, through their Committee for Environmental Protection, and in partnership with IATO, site use guidelines setting landing limits and closed or restricted zones on the more frequently visited sites. Antarctic sightseeing flights which did not land operated out of Australia and New Zealand until the fatal crash of Air New Zealand Flight 901 in the Mount Erebus disaster in 1979, which killed all 257 people aboard. Qantas resumed commercial overflights to Antarctica from Australia in the mid-1990s. About 30 countries maintain about 70 research stations, 40 year-round or permanent, and 30 summer only in Antarctica, with an approximate population of 4,000 in summer and 1,000 in winter. The ISO country code 3166-1 alpha-2 AQ is assigned to the entire continent regardless of jurisdiction. Different country calling codes and currencies are used for different settlements, depending on the administrating country. The Antarctican dollar, a souvenir item sold in the United States and Canada, is not legal tender. Research. Each year, scientists from 28 nations conduct experiments not reproducible in any other place in the world. In the summer, more than 4,000 scientists operate research stations. This number decreases to just over 1,000 in the winter. McMurdo Station, which is the largest research station in Antarctica, is capable of housing more than 1,000 scientists, visitors, and tourists. Researchers include biologists, geologists, oceanographers, physicists, astronomers, glaciologists, and meteorologists. Geologists tend to study plate tectonics, meteorites from outer space, and resources from the breakup of the supercontinent Gondwana. Glaciologists in Antarctica are concerned with the study of the history and dynamics of floating ice, seasonal snow, glaciers, and ice sheets. Biologists, in addition to examining the wildlife, are interested in how harsh temperatures and the presence of people affect adaptation and survival strategies in a wide variety of organisms. Medical physicians have made discoveries concerning the spreading of viruses and the body's response to extreme seasonal temperatures. Since the 1970s, an important focus of study has been the ozone layer in the atmosphere above Antarctica. In 1985, it was eventually determined that the destruction of the ozone was caused by chlorofluorocarbons, CFC, emitted by human product. With the ban of CFC in the Montreal Protocol of 1989, climate projections indicate that the ozone layer will return to 1980 levels between 2050 and 2070. In 2007, the Polar Geospatial Center was founded. The Polar Geospatial Center uses geospatial and remote sensing technology to provide mapping services to American federally funded research teams. Currently, the Polar Geospatial Center can image all of Antarctica at 500 mm20 in resolution every 45 days. In 2007, the Belgian-based International Polar Foundation unveiled the Princess Elizabeth Station, the world's first zero-emissions polar science station in Antarctica, to research climate change. The prefabricated station, which is part of the International Polar Year, was shipped to the South Pole from Belgium by the end of 2008 to monitor the health of the polar regions. The project includes research in climatology, glaciology, and microbiology. Astrophysics. Astrophysicists at Amundsen Scott South Pole Station study the celestial dome and cosmic microwave background radiation. Many astronomical observations are better made from the interior of Antarctica than from most surface locations because of the high elevation, which results in a thin atmosphere, low temperature, which minimizes the amount of water vapor in the atmosphere, and absence of light pollution, thus allowing for a view of space clearer than anywhere else on Earth. Antarctic ice serves as both the shield and the detection medium for the largest neutrino telescope in the world, the IceCube Neutrino Observatory, built 2 km 1.2 mi below Amundsen Scott Station. Meteorites from Antarctica are an important area of study of material formed early in the solar system. Most are thought to come from asteroids, but some may have originated on larger planets. The first meteorite was found in 1912 and named the Weddell Land meteorite. In 1969, a Japanese expedition discovered 9 meteorites. Most of these meteorites have fallen onto the ice sheet in the last million years. The motion of the ice sheet tends to concentrate the meteorites at blocking locations such as mountain ranges, with wind erosion bringing them to the surface after centuries beneath accumulated snowfall. Compared with meteorites collected in more temperate regions on Earth, the Antarctic meteorites are well preserved. This large collection of meteorites allows a better understanding of the abundance of meteorite types in the solar system and how meteorites relate to asteroids and comets. New types of meteorites and rare meteorites have been found. Among these are pieces blasted off the Moon and Mars by impacts. These specimens, particularly Alhiti 4001 discovered by Ansmit, were at the center of the controversy about possible evidence of microbial life on Mars. Because meteorites in space absorb and record cosmic radiation, the time elapsed since the meteorite hit the Earth can be determined from laboratory studies. The elapsed time since fall, or terrestrial residence age, of a meteorite represents more information that might be useful in environmental studies of Antarctic ice sheets.